So the region is bounded by y equals x squared, x equals 1, y equals 0. Okay, and also assume that x is greater than or equal to 0. So it's generated about the y-axis. So the region is bounded by those equations, as a curve determined by those equations. And you rotate that region in the xy plane about the y-axis. My question is set up two integrals, okay, using cylindrical shells and disks to for the volume. You have to draw the 3D graph for each of the integrals, and then you don't evaluate the integral. Just I want to see two integrals. This is a yeah. I need the two integrals. Maybe one is using x variable, other one is y variable. We don't know. Okay. You have to draw the graph for each method you're going to use. All right, time is up. Step 1, you have to draw the 3D, right? There's a region in the xy plane. So y equals x squared, x equals 1, y equals 0, x is greater than 0, right? So that is the region. Yeah. All right, and you're going to locate about the y-axis. So that's a 2D. So the first method, this is a picture, right? The first method, you have to use a discs to set up integral. Right? How do you use this? Cut the solid into using the flat knife, right? That's a 3D picture. So you get a cross section, right? Right. So, so this family, the original parameter actually is a distance of the plane to the xz plane, right? So, but this distance, yeah, I just want to use a mutual parameter. So that's suppose R. So that cross section area is AR. So the volume is going to be integral of AR dr. Okay. So the intersection point here is going to be 1 and the 1, right? So I is between 0 and the 1, clear. The highest value for I is, the largest value for I is 1. The smallest value is 0. Right? Then choose this cross section, right? The y value is fixed. Okay, the y value is fixed. This is going to be the radius little r. This is going to be R1. It's going to be R2, right? So you get 2 disks. Right. So what we should know for the clearly I is going to be y value. So some people just write the y value first. Why? Using the y variable directly. Okay. So how can I get R2 and R1? Because A over R is going to be pi R2 square minus pi R1 square. So you have to express it in terms of R, little r. Right? How can I get R2 for the fixed y variable? For the fixed y variable, R2 is actually constant, right? It really doesn't matter. It's always constant from here, right? It's equal to 1. So R2 is always constant. It's 1. But R1 depends on the parabola. It depends on the parabola. It's going to be the x value at that point. For the fixed y equals x squared. X is going to be square root of square y. Okay. So that's what I want to see. Okay. Then you're going to be get 1 square plus y square. Now you can use a y variable for the x for the r, or you can replace r. So some still maybe just simply write pi minus pi y dy. Okay, that's okay because I equals 1. You can also use r for the integral. So this is going to be the integral form. This is going to be integral for the volume. Second method, cylindrical shells. Okay, you only get 1 correct means you only get 50% correct for this because sometimes you are forced to use a specific method to set up integral. If you use a different method, we don't count that. Okay, we want to test whether you know how to use a disk to set up integral. Okay, for the cylindrical shells, so this is a picture again. Right. Okay. So this time I'm going to concede the cylinders with the same distance to the axis. So I use a cylinder to, those are the cylinder I'm going to use, right, to cut. So what I got here is a cylinder inside. Okay, this is a cross section. Right. Right, so this is a cylinder. So what is R here? This is R, right? The prime. R changes, the cylinder changes. If that one, the surface area is denoted by R, the cross section, okay, then you still have the same volume formula, okay? And then what is the largest, smallest value for R? 0. What is the largest possible value for R is 1. You get same formula. This is our original formula. Right? The area times the thickness is going to be the volume, right? Right. So how can you can keep using the variable R. You can change it to the X variable, you can change it to Y variable, really, it doesn't matter here. So there's two options for this problem. Okay, the mutual variable is R. Okay, you can change it to X, you can change it to Y variable, that really doesn't matter. So using this point, X and Y, right? First of all, A of R, it's a cylinder. The area of the cylinder is 2 pi RH. So if we are able to express H in terms of R, then you don't need to change it to any other variable. Okay. Right? Clear. So what is R? R is going to be X for that particular point. And H is Y. Right? H is Y. Right? But Y and X are left. Y equals X squared, X equals square Y. That depends on which variable we're going to use, right? Or if you really don't, if you still want to use R, because X equals R, so that's your R squared, right? So that is 2 pi R squared. Okay, so the volume is going to be integral 2 pi R cube dr. That's it. So this is it. I did not use X, I did use Y variable. But you can easily change it to X variable, okay? X equals Y, X equals R, 2 pi X. If you get this, you're right, okay? But if you can also get the Y variable, the Y variable is a little bit complicated because the reason is X is equal to R, right? dr, right? So R equals X, but X is going to be square Y. If you really want to use the Y variable, then I equals this, and then dr equals dy, right? That's a problem here, right? Yeah, di is going to be this. So the volume is going to integral A of R 2 pi. Everything should be in terms of Y. So I is going to be square Y, right? I is going to be square Y. H is Y. Very simple, right? This is R, this is H, okay? And the dr is going to be this. This is the dr. And the R start from 0 to 1. It will be Y start from 0 to 1. And surprised, it's even simpler. Just integral this. Okay? Yeah, the answer is going to be pi, half pi. The same, if you want to evaluate it, it's half pi. Okay. And here, this is going to be half pi too, because it's the antiderivative of this is 1/4 of R cubed. R to force X to force power, but that's 2 pi over 4. So still pi over 2. Okay. Okay, it's the same answer, no matter which method you use. If you go back to here, it's the same answer. Okay, is disks the antiderivative is y minus half of y squared, evaluate the end point, and it's still going to be half. So it doesn't matter which way you go. Get power 2. Okay, so if you are able to set up 2 integrals correctly, then for the second is the cylindrical shells, you have 3 options: r, x, and y. Most common formula will be the formula using x variable. So only formula you should memorize just the integral, the area of the cross section, right, times the thickness and the integral. Don't memorize the formula like f of x, but 2 pi f of x, without understanding what does f of x mean in that formula. Because the notation could be about y-axis, could be about x-axis. You have to understand why you have to put that on, right? No matter what job you're going to do, you need to understand. You cannot just look at the manual, put this part here, put that part here without understanding. You're not going to do a good job. Even even you go out to fix the furnaces, you really need to open the cover and you need to understand all those parts, the theory. Okay, you cannot just look at the manual without understanding. Yeah, brand new is okay. Just follow the. Put a screw here, put a screw there, and set up. It's working. No problem. Just understand it. So manual is like a formula here. We use a formula. Okay, but if you want to fix the problem later on, then you really needed to understand. So, yeah, I'm teaching calculus. I'm also good at fixing furnaces. It's when the furnace was broken, I just went there. I pull out the one small tube, blow the air into it, and plug it back. 1 minute, so save me $100 all the time also. But I understand all the circuit board. Yeah, I'm not good at the electronic engineering, but I understand this part. All right. All right. So this is a review. Okay. So please, I already post all the notes. Sometimes the video will be delayed. If it reminds me, I will post that. The reason I have to convert it to MP4 file and upload, okay, that takes time. But the lecture notes will be posted immediately most of the time. Okay? So when you look at those problems, yeah, try and do it by yourself, and you look at how did I do that. Okay, solution is not just only the answer. It's consists of the formula, picture, everything. Okay. What is the last thing? How to define the average value? That's the question. Okay? If the data is continuous, we know that if you have a discrete data, the average value is easy to calculate. Suppose you take 5 tests, you get different scores. What is the average score, right? The scores add together, divide by 5. That's a reasonable definition. But if you look at the stock price, going up and down, right? Maybe it looks like a continuous. Actually, it's actually recorded every second, maybe every hour. So it's still discrete data, but very looks like a continuous data. And if you are able to, the question: how do you find the average value of a particular during a particular day, right? Then you needed to derive the formula. Okay. So my question is, if you have a function value, it's from A to B. If it's constant, I know the average value is the same number. But if it goes up, down, right? What is the average value? How to define it, right? Okay. So how to define the average value? And we have to use the calculus idea. I'm not going to just give you the formula without understanding, because someday late you have to face another problem without any formula given. So you have to derive the formula by yourself. Okay. So you needed to understand the calculus idea. How do we derive the formula? Yeah, how to find the average of this function, okay, over the interval. The idea is you divide the interval into many subintervals. And we assume that this delta xi is very small. Right? So over that small interval, the value is almost the same. The function is almost the same. So here you see that, right? Maybe the whole picture, the whole graph may be up and down, right? But if you shrink, narrow, shrink the interval into very kind of small interval, the function almost takes the same. It's almost constant. Okay. So so all you have to do is just look at the values at those numbers. So the average value should be, okay, the average value we denote by this should be almost equal to the average value of those numbers. Divided by n. Do you agree, right? You divide the whole interval into many subintervals, many points. You pick up many points in the interval. So they're getting the distance between the nearby points is getting small. Okay. So you then look at the value function at those numbers, you get discrete data. You add them together, divide by n. This should be almost equal to the average value. Then I want to take the limit. The problem is, wait a minute. Yeah, I have to. I needed to make sure this is the same. Yeah, distribute evenly. So otherwise there'll be trouble here to calculate. Okay, so that is going to be. We assume. Yeah. I assume that the nearby, it's b minus n divided by n, and xi is going to be a plus I delta x. Okay, so all the subintervals have the same length. All right. Then let me erase this. All right, so I'm going to try to find the limit of this when n is sufficient large. So what do I get here is this sigma I is f of xi and divided by n, right? But according to the formula for the delta x, this is going to be f of xi delta x, and you have to divide by b minus a. Okay, because 1 over n is going to be delta x divided by b minus a. So if you press that, then the numerator is Riemann sum. So clearly when n approaches infinity, the denominator is the same number. The numerator is going to be the integral of the function. Okay, integral function. So that is going to be the average value of the function. All right. So take a look at this following example. Okay. So here the function equals, then we have the formula, right? The formula is going to be, the average value is going to be, is the integral of the function divided by the length of the interval. So if you have x cubed, x is between 0 and 1. So let's draw the graph. Okay. This goes like that. Okay, very sharp. And the value of function between 0 and 1. Some is very large, some is very small. So what is the average value of this function? All right, And what is appropriate definition of the average value, right? So average value, according to our formula, is going to be integral from 0 to 1 x cubed dx and 1 minus 0. So the entire derivative is quarter x cubed, x to the fourth power. So the answer is just 1/4. So one quarter is here. So the average value is just only 1/4. Even somewhere the function, the value of the function is 1, almost 1. But the majority of the portion of the graph is below the line y equals 1/4. Okay. So yeah, it's possible it looks like that. I did not draw the graph very precisely. It probably looks like that. Okay. So over a larger interval, right? Over the larger interval, the function is smaller than 1/4. So that's why the reason the average value is just the average value actually is getting smaller and smaller when the function n is getting larger and larger. Okay, so in this case, the average value of the function, if we evaluate, okay, it's going to be 1 over n plus 1. So clearly, when n is larger and larger, the average value of the function is getting smaller and smaller over the interval from 0 to 1. Right. The reason is x to the nth power is a very small number. But of course, when x is getting close to 1, this number is getting close to 1. But for any x smaller than 1, when n is sufficient large, x to the power n is really is very small number. Okay, that's the reason is xn approaches 0, n approaches infinity for x less than 1. For x less than 1, greater than or equal to 0. Okay. So as long as x is less than 1 and x to the power n approaches 0 as n increases. Okay. So you get when n increases, you get family of curves, family of graphs, then that just collapse to the x-axis. Okay. So this is a picture, and here's the original, right? Then you have the second one. Then you have the third one, like that. Okay, it's going, it collapsed to the x-axis. All right. So now let's look at the example. Once we know the formula, the problem is simple. Okay, let's look at the example. Y equals sine x. X is between 0 and pi. Okay. This is a sine x. This is a pi. That's x-axis, y-axis. We really want to know the average value of this function. And of course, the average value is, let's guess. Look at the picture. Let's guess, right? And is the average value is larger than 1/2 or smaller than 1/2? Let's draw the line 1/2, right? This is a pi over 6. This is a 5 pi over 6. Okay. So So I think that's more over the larger. The interval of this is 2 pi over 3. So over two-thirds of the interval, the value of the function is greater than 1/2, right? Only over 1/3 of the interval, the value of the function is less than 1/2. So I think the average value should be greater than 1/2. Based on that, right? Yeah, there is, right? Over a longer interval, the average value is going to be, yeah. So, yeah, 2/3 of the interval. Over the 2/3 of the interval, the value of the function is greater than 1/2. So I'm pretty sure before I solve the problem, I know this should be greater than 1/2, right, from the graph. So let's figure it out. So the average value is going to be integral from 0 to pi sine x dx divided by pi minus 0. Okay, and the integral of sine x from 0 to x is 2. Okay, it's just equal to 2. We did that before. So 2 over pi is greater than 1/2. It's greater than 1/2. Obvious. Why it's obvious? Because 4 is greater than pi. Right? Now, another problem is we want to determine the interval so that the average value is given is equal to a given number. Okay. So we want to find B such that the average value of f x to 2 plus 6x minus 3x squared on the interval from 0 to b is equal to 3. Now, what does that mean? Clearly, f of 0 is 2, right? The value of the function is 2. So when x equals 0, the value is 2. It's possible the function increases here, right? So the average value over the interval from 0 to b may be larger than 2. I want to find out